Hello guys, welcome to Ramta Solutions. Today we are looking at infinite series. So without any waste of time, let's consider these expressions. 1 plus, let me use a black color. 1 plus 2 plus 3 plus 4. Then look at 5 plus 10 plus 20 plus 40 and so forth. Lastly, we look at 9 plus 3 plus 1 plus 1 over 3 plus and so forth. When you look at these series, the first one, when you add, say you want the sum of the first three, the more you add, the more your sum changes. So every time your number of terms increases, your sum of terms increases, right? Same applies to the second one. But when you look at this one, the third one, when your number of terms increases, you then realize that this somehow has stopped. I'm approaching a certain number, right? As we increase the number of terms, you realize that this series is getting closer and closer to that number. Okay, so these two are the ones we call divergent series, right? They are the ones we call divergent series, while this one we call it convergent series. We call it convergent because it approaches a certain number. So maybe let me put it in better state. When we talk of a divergent series, is that they do not get closer to a certain number as the number of terms increase, right? But when we look at a convergent series, they get closer to a certain number as the number of terms increase. Okay, now something you should know: all arithmetic sequences or series, okay, all arithmetic series are divergent. Remember, I said it's divergent when a number of terms increases, you get a different sum, right? But with the convergent, when a number of terms increases, you somehow get closer to a certain number, right? So I repeat, all arithmetic series are divergent, but not all geometric series are divergent, right? So those that are divergent are all arithmetic. Let me write it down: all arithmetic and some geometric, right? Some geometric. Again, which ones are divergent? Are convergent, sorry. Some geometric are convergent. Now, how do you know that a series is convergent, a geometric series is convergent? When the common ratio is greater than -1 but less than 1. Remember, a series is convergent if and only if r is greater than -1 but less than 1. This is the condition. Remember, when your r is greater than -1 but less than 1, this is when your series is convergent. Now, a series that's convergent, we know that geometric series have the formula Sn equals a into 1 minus r to the n over 1 minus r. This one we use when r is less than 1. Again, we know that Sn is equal to a into 1 minus, into r to the n minus 1 all over r minus 1. This one is the one where we know we use it when r is greater than 1, right? But we had said, given r is greater than -1 but less than 1, we can use this one here. However, it reduces to, because it is now convergent. When we say convergent, we say no matter how much you add, you increase your number of terms, it'll get closer to a certain number. So we will say it doesn't matter the number of terms you have, hence I'm using infinities. So sum to infinity will then be a over 1 minus r. Okay? Because we said as n increases, the series gets closer to a certain number. So we then use sum to infinity. Right? We then use sum to infinity. So this is for series that converge. It is for series that converge. So if your series converge, you use sum to infinity. And what I want to say is that when you find your r values are greater than -1 but less than 1, use this formula. Okay? Use this formula. You will be good to go. Now, let me explain something. I know what I'm about to explain will help you a great deal. -2, -1, 0, 1. This is your value. I also mean your -0,5, your positive 0,5, your negative your 0,99 and stuff. If your r value lies somewhere here, okay, if your r value lies somewhere here, okay, if it lies somewhere here, this is when you use this formula. Okay, this is when you use this formula. All right, guys, when your r value lies somewhere here, this is where you say sum to infinity is a over 1 minus r. Now let's try an example and conclude this. Example: find sum to infinity for number 1, 18 plus 6 plus 2 and so forth. Number 2, 1 over 3 plus 1 plus, let me see, will it work? Okay, 1 over 3 plus 3 plus 9 plus and so forth. Number 3, I will try 9 plus 3 plus 1 plus 1 over 3 and so forth. Right? Okay. So sometimes you look at your thingy, you look at your series and you ask yourself, hey, do you converge or diverge? So let's look at it. Number 1, our solutions. Number 1, we had 18 plus 6 plus 2 and so forth. Our A, I can see it's 8. Our R is T2 over T1 because it's a geometric series, which is 6 over 18. What is this? This is 1 over 3. Guys, 1 over 3 is similar to 0,33. So 0,33. This means series converges, right? So it converges. Therefore, this converges. Therefore, I can find sum to infinity, which is a over 1 minus r, which is 18 over 1 minus 1 over 3. Okay? Let's see. 18 over 1 minus 1 over 3. So it converges to 27. The sum converges to 27. Okay? The sum converges to 27. So sum to infinity is 27. Okay, remember I said it converges. Why? Because r is greater than -1 but less than 1. 0.33 is less than 1 and it is greater than -1. So it's what we're looking for. Number 2, we had 1 over 3 plus 1 plus 3 plus 9 and so forth. I know our A is 1 over 3. Our R, again, it's T2 over T1. What is T2? It's 1. What is T1? It's 1 over 3. What is this? Our R is 3. So here does not converge. Right? Does not converge. Remember, we said R must be less than 1. Must be greater than -1, but less than 1. Remember, less than 1. 3 is not less than 1. 3 is greater than 1. So this does not converge. So you cannot find sum to infinity. I leave it here. Okay. Number 3. Number 3, we say 9 plus 3 plus 1 plus 1 over 3 and so forth. This one, our A is 9, our R is term 2 over term 1. What is term 2? It's 3. What is term 1? It's 9. This is 1 over 3. Right? This is 1 over 3. 1 over 3 is basically 0.33. So this converges. Right? This converges. Now when it converges, what do? We say sum to infinity equals A over 1 minus R, which is 9 over 1 minus 1 over 3. Let's look at it. So this is 13,5, i.e. 27 over 2. So it's 13,5. Okay, 13,5. Okay, so why didn't I write sum to infinity of this number? I didn't write sum to infinity of this number because it is not a convergent geometric series. It's a divergent geometric series. So I cannot, the question asked me to calculate sum to infinity. This, we cannot say we calculate sum to infinity because it does not converge. It diverges. Okay? Alright guys, see you next time. Bye bye.